Hello everybody. Today we're going to be talking about polynomials and how we can get some basic ideas of their shapes and how they look and where they cross the x-axis. Right, so a polynomial is just an algebraic expression where all the exponents have to have non-negative integers on them in order for it to be considered a polynomial. So we look down the left here, we can start off with this guy here. So notice we have a square, it's the first power, then there's no x. So that is a polynomial because they're all non-negative exponents. Here, again, yes, because we only have x to the first. When we look at this one, we got x to the seventh, x to the fourth, no x's, and just an x. So those are all positive integers, So that is a polynomial. So now notice here, we have a negative exponent, so that makes it not a polynomial. And also remember that if you have like something like 1 over, I cannot write on this thing at all, so it's going to look like crap. Horrible. Alright, so like 1 over x. So that's the same thing as a negative exponent. So that is not a polynomial either. So then we look down here. We'll try this a different way. 1/2 is an exponent. That is not a polynomial because that is not a integer. So remember, 1/2 power is the same thing as something like this. Turn it out a little better. The square root. So anytime there's a radical with a variable inside of it, it is not a polynomial. I hope that makes sense. Alright, so we can tell the degree of this as well by looking here. The degree is just the biggest exponent if it's in standard form, or you count the number of variables in factored form. So if we look at this guy right here, so this one has the 5th power, 3, 2, or sorry, 1. So 5, 3, 1. So this one has a degree of 5 because that is the biggest exponent on the variable, and we are in standard form. So this one in factored form, all we do is we go through and we just count up the number of x's. So we got a square on this one, so we have to go 1, 2, 3, 4. So this one has a degree of 4. So notice that's an odd degree and this is an even degree. So that's what we're going to move on to next here. So even degree polynomials, you think of quadratics, that's the easiest example. Notice what they always do. Both ends of them always shoot off in the same direction. And thinking back to our quadratics unit, we know that the leading coefficient here is positive because it opens up. And if the leading coefficient is negative, it opens down. So we'll talk about the domain and range about these here in a future section, but right now we're just going to do the basics. So this one, again, notice even because it's opening up, and this one's even because they're both opening down. So positive orientation, negative. So the reason this one has humps in it is just because it's a higher degree. Like this could be an x to the 4th, x to the 6th, x to the 8th, the same thing here, except there'd be a negative out in front of it. So odd degree polynomials always shoot off in two different directions. And when their leading coefficient is positive, this is how they look. So as we go back to negative infinity, it goes on our domain, the range goes to negative infinity. And as we go to positive infinity with our domain, the range goes to infinity. So they shoot off in two different directions. So the positive here, again, is the higher degree polynomial. But notice the shape. Now if there was a negative in front of it, it flips it all over, so it shoots up forever back here. And then as we go forward in our domain, it goes down in our range with that negative out front. And that's just another example of that right there. Alright, and we can also tell a lot about how the root actually looks if we look at the exponent that's actually on the variable. So whenever it's just an x to the first power, that means it just crosses through the x-axis nice and neat once. So like that's an example of a single root. That's an example of a single root. And those would all have some sort of equation with just an x to the first power there. So with this one, a double root means there's an even exponent on it. So that would be like a square to the 4th power, to the 6th power. But we're mainly probably just going to focus with squares, so we're just going to call this a double root. But when a double root hits the x-axis, it just hits the x-axis and shoots back off. So We've seen these before when we've graphed quadratics. And it can also come from the bottom. This is really hard to do here, so I'm just trying to not make it look like a 2-year-old. So just touches the x-axis once. That one kind of missed, but you get the idea. Now a triple root, when it crosses through the x-axis, we're just going to say it does a little wiggle. So it's going to wiggle through the x-axis, and it could be coming from up here as well, and a wiggle through the x-axis. I'm going to try to move those to be, it's like the wiggle should kind of happen. That's a good example right there, right at the x-axis. And we're going to learn more about this, but this is just the basics right now. I'm going to talk about how we can graph polynomials. So the first thing we want to do is figure out the degree. So we add up the number of x's because it's in factored form. 1, 2, 3, 4. So we know it's a positive, or we have a 4th degree, so it's even degree. And now we look at it and we notice out here there's no negative sign. So that means this thing's positively oriented. So it's even and positive. So we know it's going to look something like this, because it's going to be opening up from what we just talked about. So now what we do is we go through and look and see what makes them 0. So 4 makes it 0. So we cross a 4. 1, 2, 3, 4. Positive 5 makes it 0. So we cross it. Positive 5. And then here we got negative 2. And here we got negative 3. So it's going to be kind of hard for me to do this on my computer screen, but I'm going to do the best I can. So we want it to have that general shape. So we're going to start right here and just kind of try to come down through that point the best I can, then back up, and then come back over here. So not the best picture of a graph, but the general idea there. So 4th degree polynomial, and it's positively oriented, so that's why we made it shoot up on both ends. It's an odd degree because we can go through and we count them up. 1, 2, 3, 4. We gotta count that 3 times. So it's got a cube on it. 5. So this is an odd degree, so it's gonna look like that because it is also positively oriented. So we're just gonna go down and graph our roots. So I'm gonna go through and put a root at positive 2. So there's our positive 2. I'm gonna put a root at negative 2. Notice that's got a cube on it. So make that a little bigger to remind me that that's my triple root. So we're going to have to do something special there. And then we have a root at negative 6. It's just another single root. 3, 4, 5. There's negative 6. So we know it should have this general shape. So what we're going to do here is just start down here and start drawing up and get through at negative 6. And then we're going to come back down. And since this is the triple root, we got to do that wiggle through the x-axis. And then we're going to come back up right through positive 2. Put our arrows on. So that would be our just quick sketch. You know, we're not getting the relative maxes and mins right now, you know, this high point and this low point accurate. And we'll worry about all that later. But right now we just want to be able to do this, you know, without a calculator, without you know, just being able to come up with a general picture in our head. Alright. So now let's take a look at this one. Oh, look at that. We got a negative in front of it. So it's negatively oriented. We're going to add up the number of x's to see the degree. So there's 3, 4, 5. Odd degree, negatively oriented means it's going to have this shape. Remember, it flips it over. Alright. So we're going to go through and just figure out where all our points are at. Negative 4. We got a triple root there. Triple root at negative 4. Positive 3 is single root, and then negative 2 a single root. So since it looks like this, we're going to come from up here now to go through our first point. Remember, our first point is the triple root, so I got to put that wiggle in it, and then we just have 2 more single roots that just cross through nice and neat. And that would be our graph. Again, we'll talk about these relative max and mins later. Alright, so here's one more. So, tell me what the degree is. Good job. It is 3. Is this positive or negatively oriented? Good job. It's negatively oriented. So we know it's going to have this general shape that we just talked about again. And this one is just all single roots. So we have a negative 5. So I'm going to put that down here. 4, negative 5. Positive 9. 1, 2. and then -1. So now we just have to cross through these points the best we can. And there. You get the idea. Alright, so that's what I'm hoping we can do today and not have much problem with it. We will be talking about the domain and range of even and odd degree polynomials. Kind of easy to figure out. And we will learn methods to graph them more accurately here soon. Alright, hope everybody's having a good, not break, but non-traditional instructional days.